Hi, everyone. We are very excited to be here. My name is Carlos Avila. I'm from Ecuador, and I work as security research at 11 Path. It's a Telefonica Tech cybersecurity unit, and this is my partner, Diego. Diego?
Hi, Charlie. Hi, everyone. I'm very excited to be here too. My name is Diego Espitia. I'm from Colombia. I work as a security research in Telefonica Tech Cybersecurity, and I like to show you our investigation, our tool in this event.
So, first of all, this is a project that wouldn't be possible without this incredible team that you see on this slide. And the main idea of PackageDNA was to develop a tool to scan package repositories and detect malicious behaviors through an open source tool. Uh, let's go, Diego. Go ahead.
Yeah, it's a very important question. The software package has become a platform widely used by cyber criminals to deploy malware in the last year. In addition to the inherent risks of the developing community and ecosystem when uploading a code package to repository without the current security validation, this is very usual because the different developers now have secure life cycle. For this reason, the package can could have vulnerabilities due to lack to maintenance, among the other problems that will be demonstrated with our research. Um, all true. There are there are tools code analysis for each programming language. Now then, performing deep analysis that cover develop enumeration, hash checking, a code analysis, um, indicator of compromise, CV vulnerabilities, etc., as package DNAs does. For this reason, the community need uh, a tool with this. Was the motivation to develop this tool to provide a full deep programming package analysis. For this reason, package DNA allow automate the analysis of exist software package in different code repositories, such as Py for Python, RubyGems for Ruby, Golang for Go, npm for JS, and the others repositories. Our idea was to create a framework that integrate all necessary tools to carry out investigations, detect anomalous parents, and at the same time software failures.
Okay. Now we see how it developed and how package DNA works inside. PackageDNA is a modular open source tool developed in Python 3 and interact with other API services like libraries.io, npm, and other repositories, RubyGem, etc. Um, with this tool, developers and researchers can analyze the packages used in their development. You can collect data from who developed the package, hashes of the files that compose it, identify bad development practices, reported vulnerabilities like CVEs, and perform analysis with typo-squatting techniques of the package, among others. Once the package analysis is done, the tools displays the results in the console and runs a web server where it displays a web application with the results.
Yeah, Charlie. Now we would like to show you the main feature about package DNA. The three main features start with static analysis. It's very important because this type of analysis using different tools, the static code analysis depend of the type language of the language, and the goal is a performance search, a bad practice and potential security flags detect for this type of analysis. The second feature is the malicious behavior detection. Uh, in this feature, the malicious file embedded in package can be detected. In addition, the behavior such as possible connection, encoded string, hardcode data. In general, the potential indicator of a compromise have could into the package. And the last one feature is the intelligence. It's very important in cybersecurity when you can do intelligence. For this reason, we integrate this possibility in the framework. Other analysis are carried out such type squatting, search for malicious package, or package use the branding package for distribute malware, profile repository users. If you can understand the different develops words in the repository, search for piece of code for identification bad practice or malicious codes, and identify no CVS.
Well, this is package DNA in the console, the, but the first thing will be to configure the parameters in option 7, configure the path and the API of the components that it uses internally. So Diego talked about the modules and features, but let's go package DNA in action, in demo time.
Is the demo
So,
time. Go ahead.
yes, we prepare 3 demos, and the first one is this. Okay, yeah. In this demo, we will perform the analysis of a Python package from the same machine, the local machine. We choose option 3 from the main menu. We write the path where our package is located, and the security analysis will start executing all its functionality. Okay, and after that, in case of detecting an anomalous file within the package, it will perform the analysis using VirusTotal. We can use this type of analysis before integrating a package into the development life cycle of our project. Now we can observe the results in the console and the more friendly way in the PackageDNA web application. Okay. Among the results, we can view the metadata of the package, the hash of each file, a feature of PackageDNA. The important feature is to extract possible IOCs or indicator of compromise or group of data such as URLs, hashes, IPs, addresses, emails. Um, so that later you can investigate them in detail with this type of data. And based on bandit components, we can obtain the bug and bad development practices with the level of risk and the line of code where the bug is found. For example, in this case, you can see a high severity finding that invokes an external process in this script. Another component executed is App Inspector, where several findings are made through its analysis. In this case, for example, identify as data sensitive API key hard-coded in that script. In this other case, you can see a possible hard-coded password. In this case, in one parameter, it's a password. The password is ABC123 into the code. Okay, and in this analysis, no CVEs or associated packages were found in typo squaring analysis, and in this analysis, PackageDNA has detected a file. You can see that in analysis virus total suspicious files, has detected a file into the package where the virus total analysis identified with classified is a malicious file. 59 and James exactly identify like malware. And we can see the results in that link. The next one is the demo 2. Go ahead, Diego.
Okay, the demo 2 is a little different. We are gonna show that can analyze the requirements the some develop that you have. For example, a package use Ruby web developer. You select the option 5 and the option 2, and you put the different package separate by comma. In this case, action view and action widget. The system start analysis of the package and show the result on the screen, and late the menu for possibility the presentation in the web. In this case, we show the first requirement, the action view. This is the common popular package in Ruby gems. In this case is the version 5.2.3. This version is last 2 years ago. Start the metadata, data collect, very URLs, a lot of emails, and next the RubyCop, same to the last demo. In this case, we use RubyCop for this statics analysis for Ruby language. Approximately detect 30 reports. Next, the app inspector, in this case, show more than 50 detection, very critical, like authentication, HTML, data, credit cards, bad authentication, data sensible is very important results for this tool. The next is the most important for this demo, is the reports, the CVS that are on GitHub. For this case, action view for this version has 3 dynamic. You can see the 3 different reports, and you show the about old report with the link. Next, the CDS, the system analyze type squatting. For this case, only two possible detection and no exists reports in virus total. And next, the system show the old package that developed for different maintainers of the action viewer. If you want look the other package of the other package in the list, you only select the other option in the console. The next three demo, Charlie.
Okay. You can use you can saw in the demo 1 and 2 find the package DNA to finding bugs and bad practices in code. But in the demo 3 is the next one. Let me check. Okay. In the demo 3, you can use package DNA to do package investigation for threat hunting or malware research, something like that. And in the option 4, you can throw a username search for package developed with that username in repositories such as PyPy, RubyGem, NPM, GitHub, and Bitbucket. For example, in this case, the username is WebM, and with this functionality, you could detect possible malicious packages that were deployed in a malware campaign with that username, for example. This is not the case, but it's only an example. For example, in this case, you have different projects about this about that user in Python, Ruby, and GitHub, for example, and Bitbucket don't package were found. And you can do type of squatting analysis to search for possible malicious package and related them in your investigation. We use several type of techniques, and in this case, we will use permutation with a local file, well, local database file. And in this case, we will use an example of an npm package called bitcore list. While doing the analysis, we can see that there are 290 possibilities of package name that package DNA will consult with the API npm repository if they exist or not. And finally, we obtain the results of the combinations that exist within the npm repository. Look like this. In based on the name bitcore list and permutations, you can find different projects with a similar name, possible malware or something like that. In this model, you can throw keywords to look for those portions of code in a specific package. In this case, the npm package called tmi.js, we will look for the keyword send command. And you can put the keywords or portion of code, and we will observe in this case that this pattern was found 3 times within the package. In this case, in commands.js, in this file, three times was found the keyword send command. And the same option you could use to search for code patterns itself, a portion of code. PackageDNA saves the data of the analyzed packages and allows you to review the previous results. In case with the option 6, we can make use of the functionality once the package we want to review is selected. Its results will be able in the web application of PackageDNA. In an investigation, something interesting to analyze is the changes that the package version have undergone. Um, in the PackageDNA web application, you have the option to compare results between versions of packages. For example, in this case, the name or the metadata, the hashes that have changes in the files, that is, files that have been modified, can be seen in the hashes section. The changes are identified with a red color in PackageDNA web application. You can also compare the number of the vulnerabilities between one package and other. In this case, we observe that in bandit component. In the version of the left, script invokes a website that will later execute actions on the machine, where that package will be installed. It's very suspicious. While in the other version, can't find that function. Um, Something strange that shouldn't be analyzed. In fact, this example is taken from a real malware campaign, a real package malware. And in the end, you can also observe the type analysis carry out. You can do other type of investigation or extract other type of data in that investigation. So these are a demo, and the most important thing is what are the next steps in this case. What are the next steps for PackageDNA? So we are working to release the Dockerization version of the tool, and we plan to generate a server-side version that allows to continuously analyze the packages and store the data. Right now, the data is are saved in text files. It's a JSON file. In the other in this type of version, the idea is saved on database. Um, Generate an API for its integration with other tools. Um, we plan to continue to include support for the analysis of more programming languages or repositories, and generate plugins that allow to integrate PackageDNA analyzed in the popular IDEs. And we want to continue research new attack vectors, improve analysis performance, and other features in PackageDNA. Well, PackageDNA is an open source tool project, and you can contribute new modules or features in general from our GitHub. If you have any questions or suggestions, you have our Twitter account. So thank you very much. Thank you to Blackhat for this space.
Yeah, yeah, Charlie. Thank you for Blackhat for the opportunity. Thanks for the big team. We can work in this project. This project is open source, and we need your help for approve the software, the framework. And thank you, thank you for attend our presentation.